Okay, so as always, we read through. We've got a ball being dropped from a given distance, and we're recording the height to which it bounces, and here's some good stuff. That's normally distributed. So x is normally distributed. So x, we can say, has a normal distribution, but we always, when we write this down, say what mu equals and say what sigma equals. Okay, do we know mu? Do we know sigma? Yes, we've got a mean and a standard deviation being given. So all I've got to do here is work out two probabilities. So in each case, we do a sketch. Okay, so it always starts like that. We can mark the mean on in the middle. And then we can mark on this position of 1, 4, 5. It'll be one side or the other. And this sign here tells us to shade one side or the other. Okay, so that's the diagram. That will help us make sure we're using our limits correctly. But you're going to go into your calculator, so you're going to go, well, is this forwards or backwards? Well, we're finding probabilities, so it's forwards. So therefore, we're going to be using normal CD on your calculator, and for that we need a lower and we need an upper. Okay, and we obviously need a Z value. So Z is going to be, from the Z formula, something minus something divided by something. So you're going to get a number for Z, and that's going to be either your lower or your upper. Okay, when you've only got one Z value, you have to use your diagram to decide whether you're working from a lower limit of minus 9999 or you're working up to an upper limit of plus 99999. So one of your lower or uppers is going to be the Z you calculated, the other is going to be, might be the lower is minus 9999 or the upper is plus 99999. Okay, for the second part, we're going to have the diagram. We've got two different values, but again, you're going to put them on a diagram like this. You're going to get two Z values, one for each of these, and then, because we need to be between those, this is going to be easy. We're going to have one of those Z values as our lower, and one of our as our upper on normal CD, and that will give us the probability. Okay? So those were forwards questions. Now, if we look at part B, we've got to find a height. So we're not finding a probability, we're finding a height. And we're given this 85%, which will be a probability. So we need to draw a sketch with an 85% probability in it. Okay. And the shaded value, or the shaded area, showing that the cutoff point is the maximum height of 85% of the bounces. So you draw your menu of 4 pictures, okay, so it doesn't take long. So you draw the 4 pictures. Of course, your final diagram is going to be nice and neat, but your 4 pictures can be relatively scrappy. So one of these 4 pictures will be the one you need, okay, that shows the maximum height of the 85% of first bounces. Okay, so decide which of the pictures corresponds to the words. Once you've got that, then you then take the probability, you work with a probability, which might be the 85% or it might be the other side, because your calculator likes the probability to be to the left. So having got the p-value, you could then use your calculator on normal inverse to get a z value. Okay. Now, depending on which side your line is, you might be expecting a positive or a negative z value. Make sure your z value is positive or negative as you'd expect from your diagram. And then you use the z formula, the same formula as you used before, but you use it backwards. So you know the z value, there's something here, it's going to be a height, it's going to be an x value. You don't know. So you again put 3 things in, but this time you have to rearrange and solve. Now from part B to part C there is a change, okay? We now have a random sample of 4 first bouncers, and we're interested in the mean height. So before we were looking at the x distribution, now we're looking at the x bar distribution, because we're looking at the mean height of a sample of 4 bouncers. So that, because the original distribution was normal, okay, the x bar will also have a normal distribution, and the mean will be the same, but now I'm not interested in sigma anymore, because we work with the standard error for a sample mean. So there's a formula for the standard error. It's something over the square root of something, Okay, we need a value for n. Okay, n is the number of things in our sample, so it's going to be this 4, so we're going to be using n equals 4, so that should allow you to work out the standard error. And now we want the probability of that value, that mean, being greater than 139 centimeters. So we're back to finding a probability, so it's forwards, so you can go straight to your sketch. Okay, we know that this value in the middle is still the mean, what the mean has always been. Okay, you need to draw the line for 139 on one side or the other and do your shading, and it's very much like part A, except this time when you work out Z, we're now working out Z for a sample mean, so it's the X bar value, so that's this 139, minus something divided by the standard error this time. Okay, so once you've got that, you set up your lower and your upper as you did in part A, and you should be fine. So I'd hope that helps.